To say things have changed since 1975 when I came into business, I think would be a sort of an understatement. The one thing that hasn't changed is the successful extinguishment of a fire and or the rescue of occupants trapped in a fire demands an extremely coordinated level of operation, accomplished by firefighters that arrive at the scene with specific, predetermined job functions. These predetermined tactical functions are in large part dictated by either the type of apparatus a firefighter rides on or the order in which the apparatus arrives on the scene. In order to understand successful fire department operations, one must first understand how a fire develops from onset to decay. This process is called the stages of a fire or the fire cycle.
The first stage of any fire is the smoldering stage. Technically referred to as the incipient phase, the first phase of fire occurs when heat is applied to a combustible material and the heat oxidizes the material's surface into combustible gases. The oxidation process is exothermic, meaning that the oxidation process itself produces heat. The heat from oxidation raises the temperature of surrounding materials, which increases the rate of oxidation and begins a chemical chain reaction of heat release and burning. A fire can progress from the smoldering phase immediately or slowly, depending upon the fuel, nearby combustibles, and the availability of oxygen in the surrounding air. The second stage of fire growth is the free or open burning stage. When the temperature of a fire gets high enough, visible flames can be seen. The visible burning at this stage is still limited to the immediate area of origin. The combustible process continues to release more heat, which heats nearby objects to their ignition temperature, and they begin burning. In a structure fire, the gaseous product of combustion, most of which are flammable and lighter than air, rise and are contained in the upper levels of the structure. When this occurs, the structure fire is at a critical point. Either the fire has insufficient oxygen available to burn and it progresses back to the smoldering stage, having the potential for a backdraft, or it has sufficient oxygen available to move on to the next stage. The third stage of fire growth is called flashover. It is the most significant moment of any structure fire. As combustible gases are produced by the two previous stages, they are not wholly consumed. They rise and form a superheated gas layer at the ceiling. As the volume of this gas layer increases, it begins to bank down to the floor, heating all combustible objects regardless of their proximity to the burning object. In a typical structure fire, the gas layer at the ceiling can quickly reach temperatures of 1,500 degrees Fahrenheit. If there is enough existing oxygen, usually near floor level, flashover occurs and everything in the room breaks out into open flame at once. The instantaneous eruption of flame generates a tremendous amount of heat, smoke, and pressure with enough force to push beyond the room of origin through doors and windows. Usually at the time of flashover, windows in the room will break, allowing for the entry of fresh air. The introduction of fresh air serves to further fuel the growth of the fire, increase the temperature of the fire, and aid in the spread of the fire beyond the room of origin. The combustion process then speeds up because it has an even greater amount of heat to move to unburned objects. Flashover is a critical stage of fire growth for two reasons. First, no unprotected living thing in a room where flashover occurs will survive, and the chance of saving lives drops dramatically. Second, flashover creates a huge jump in the rate of combustion, and significantly greater amount of water is needed to reduce the burning material below its ignition temperature. A post-flashover fire burns hotter and moves faster, requires more resources for fire attack, and compounds the problems of search and rescue, exposure protection, and containment. The following video demonstrates how much time or arrival on scene has become such an important element in the successful extinguishment of a fire. The legacy room clearly shows the difference in the propagation of fire to flashover when the contents of a modern versus yesteryear room are compared.
The goal of any fire department is to arrive on the scene of a fire before flashover occurs, as this is the point in the fire where most all the contents of the structure will be lost and the rescue of any occupants will be very unlikely. It is also just before or during the flashover phase of the fire where it is the most dangerous for firefighters to be operating in the structure. Flashover is generally considered to occur at the 10-minute mark in the life cycle of an active or unrestricted fire.
Now that you understand the cycle of fire and why it is important that we arrive in a timely manner, let's talk about the various types of fire apparatus and their functional capabilities. The first and most predominant type of fire apparatus is the engine, sometimes called a pumper. This type of apparatus contains a water tank, various size water hose, pump, and a small number of ground ladders sufficient to perform fireground operations that include rescue for a typical 1 or 2 story residential fire. This type of apparatus is used primarily for transporting firefighters to the scene and for establishing water flow from the supply source and then through attack lines into the fire. The ladder truck, sometimes referred to as a truck company, is an apparatus with a ladder that can be elevated to reach the upper floors of a building. In addition to the aerial capabilities, the truck company carries ventilation fans, extrication equipment, forcible entry tools, and a large number of various size ground ladders. In much the same fashion as the engine, most modern aerial apparatus also carry a limited number of hose lines and a water pump. These units are also utilized for delivering large amounts of water into a structure on elevated floors. The rescue company has no water or pump, however, it carries a number of very specialized rescue tools. The personnel that ride this truck are trained to the highest levels of rope, confined space, trench, vehicle, and collapse rescue. Safety 2 is manned 24 hours a day with a fire department captain. Safety 2 has the responsibility of safety on the fireground and under most circumstances is the only person other than the incident commander that can order a process altered or stopped. The safety officer's role is to continually consider and communicate hazardous or unsafe conditions during an incident. Safety 2 is a suburban type vehicle. Incident command is handled by a battalion chief. His role is to provide overall management of the scene. This includes assessment of the scene, determination of the need for additional resources, and to facilitate the coordination of all outside resources.
Now that you know who responds to a fire, let's discuss deployment of those personnel.
The deployment of personnel to successfully combat a fire is based on the number of tasks that need to be accomplished. The number of tasks needed to be accomplished is based on the risk analysis profile for the structure. For instance, a modern risk single-family dwelling fire requires a deployment of 3 engines, 1 truck, 1 rescue, 1 safety officer, and 1 battalion chief for a total of 17 personnel. This effective response force is programmed to arrive within 11 minutes total response time for 90% of the requests for service. This response constitutes 30% of all available staffing in the city. A high-risk fire effective response force, which in general is a large commercial or multifamily structure, consists of 20 personnel that will respond on 4 engines, 1 truck, 1 rescue, 1 safety officer, and 1 battalion chief. These personnel will have the capability to deliver 4,500 gallons per minute of water, initiate search and rescue, establish rapid intervention, advance to attack lines, begin ventilation, control utilities, and provide for accountability, safety, and incident management. This effective response force is programmed to arrive within 12 minutes total response time for 90% of the requests for service. This response force consists of 35% of available personnel on duty. Now let's put it all together. The first apparatus should arrive on scene with a combined turnout and travel time of 7 minutes, 30 seconds. The first unit that will be arriving on scene will have an officer that is responsible for the size up. The size up is a condition assessment that will be transmitted over the radio in order to make units responding aware of conditions and type of attack that will be in progress when they arrive. While en route to the scene, the officer will also be analyzing traffic condition, clues like time of day, and cars in the driveway that would indicate persons at the home, the effect the fire is having on dwellings next to and behind the fire structure, their water supply, and whether to stop and lay a line into the fire or let other companies come to the scene and lay out from the fire to the hydrant. The first officer size up for a house fire on Pine Street would sound similar to this. Central from Engine 1. Engine 1 is on scene and will have Pine Street Command on radio channel PS2. We have a 2-story wood frame residential structure with fire showing from a window on the second floor B side of the structure. We will need a water supply established. Engine 1 crew will be initiating an offensive interior attack. After pulling past the structure, the officer will conduct a 360-degree assessment of the structure. While the officer is conducting the assessment, the firefighter will be pulling the initial attack line to the front entrance of the structure, and the driver will be putting the engine in pump and charging the hose line. After charging the initial attack line, the first engine driver will establish a second means of egress to the building by placing a ladder at a second floor window. This will provide an exit for the attack crew if the main entrance becomes compromised. The truck company assigned to the call will normally park directly in front of the structure. The truck company's main responsibility upon arrival is to make certain the engine company personnel can get into the structure. In some cases, this will be through forcible entry of the entrance door. Ventilation is another very important responsibility of the truck company. Creating openings in the structure either vertically or horizontally allows smoke and hot gases to escape, aiding in fire control and improving conditions on the inside for firefighters and occupants. Horizontal ventilation may be as simple as raking the glass from a fire window. In cases of extreme heat or when the potential for a backdraft explosion exists, which is a rapid, forceful ignition of superheated fire gases caused by an influx of oxygen, ventilation will be done by cutting a hole in the roof. Truck company personnel are also responsible for utility control. When these primary assignments are complete, truck company personnel may enter the structure and, in the case of a 2-story home, search the opposite floor or where the engine company is located. The second arriving engine company is responsible for establishing a main water supply. If the first engine stopped and laid a line from the hydrant to the fire, then they will hook the supply line to the hydrant. If the first engine passed the hydrant or went to the scene without laying a supply line, the second engine will accomplish this task. The officer from this company will also assume command from the first arriving officer if the battalion chief hasn't arrived and already taken command. After establishing a water supply, the second in engine will normally pull a backup line for the attack line and advance that line to the structure for supplying additional water on the fire or providing a backup to the first attack line. These personnel will enter the structure for suppression efforts or to perform search and rescue. The rescue company's responsibility will depend on what has been accomplished prior to their arrival. Rescue company personnel could be assigned to search and rescue, providing additional fire suppression efforts, or standing by as a rapid intervention team. This is an OSHA mandate that requires a minimum of 2 firefighters standing by for possible rescue of firefighters who are performing rescue or fire suppression activities inside a building. The third arriving engine will fill in where tactical tasks still need to be completed. In most cases, this unit's personnel are designated as a rapid intervention crew. At some point during all this activity, the battalion chief and safety officer will arrive and perform their assigned task. This includes assigning additional units, providing on-scene accountability, and monitoring all fireground activities for unsafe and or dangerous conditions. While all of this activity is being accomplished, the 2nd Battalion Chief will first reassign resources not already committed in order to balance the coverage in the city. This will take place while they are responding to the fire scene to assist the fire scene commander.
As you can see, the successful outcome in a fire incident is determined by a timely response to the incident from a predetermined number of personnel who, depending on the type of incident and type of apparatus they are riding on, have pre-designated assignments. Keep in mind that the scenario just described was not a complex fire, but rather what we call a bread and butter type incident. In general, everything demonstrated here must take place within the first 10 minutes of the fire cycle. This is the reason that strategic deployment of apparatus and standard of cover regarding personnel are so important to saving property and lives. In closing, we would like to thank you for taking time to watch this video. We hope that you have a better understanding of fire department operations and our desire to provide excellence through service for our citizens, our businesses, and the visitors to this great city.